In this class, we are going to be looking at integration. We're going to start by looking at the basics of integration. We will look at the arbitrary constants, the meaning of general solution, and the meaning of particular solution. And towards the end of this class, we are going to be looking at some examples using direct integration. There's going to be a bonus section for you at the end of this tutorial. It's going to be in form of an exercise which you can attempt and solve on your own. If you have any problems solving the questions, you can post your problems in the comment section below or reach us on our Gmail. The link is being shared below. Before we begin this class fully, there are some concepts that we have to re-establish. And the first one is that integration is a reverse process of differentiation. I take that again. Integration is a reverse process of differentiation. If y is a function of x, we represent the derivative of y with respect to x by dy over dx. For example, if you have y which is a function of x, we represent the derivative of y as dy over dx. To illustrate this further, let's take, for example, if you are given y equal to x squared. From differentiation, we know that dy over dx, which is the, let me write this. We know that dy over dx, which is the derivative of y, to be equal to 2x. So, for example, let's assume that we are not given y. So we are given only dy over dx equal to 2x. So how do we find y? This is the major question that integration poses. We are given the derivative of an expression as this. So how do we get y? And this is the reason why integration is referred to as antiderivative. Again, integration is referred to as antiderivative, and it is shown by a symbol. It looks like an elongated s by an elongated x. For example, the antiderivative of x is x squared over 2. So the antiderivative of x equal to x squared over 2. Why do we say this? Because if y equal to x squared over 2, then changing y over changing x, which is the derivative of y, equals to x. And this is what we are going to be looking at in the tutorial. We are going to be looking at how we get the antiderivative of x to be equal to x squared over 2. In general, if you have an expression which is x to the power of n, then the antiderivative of x to the power of n is given as x to the power of n plus 1 over n plus 1. Take note of this. If you have an expression which is x to the power of n, then the antiderivative, which is also the integration or integral of x to the power of n, equals to x to the power of n plus 1 over n plus 1. So let us look at the arbitrary constant. What is being referred to as the arbitrary constant in integration? Now note that if y equal to x squared divided by 2, then we can say that dy over dx equal to x. So we can try to say that x squared over 2 is an antiderivative of x. Also note that if y equal to x squared over 2 plus 5, then also dy over dx equal to x. Why do we say this? Recall from differentiation that the derivative of a constant such as 5 or any number equals to 0. So we can say that derivative of x squared over 2 equals to x, and also derivative of x squared over 2 plus 5 also equals to x. So what is this telling us? That if you have y equal to x squared over 2 plus a constant, which is any number, it can be any number, then dy over dx equals to x. And in the beginning of this tutorial, we already mentioned that if you are given an integration problem, what we are simply looking for is the y. So if you have dy over dx to be equal to a particular expression, then if you are looking for the y, which is the integral of, let's change this to g of x, then the integral of g of x equal to a particular constant plus c. So it's possible for us to have any constant added to our original equation, in as much as whenever we differentiate a constant, we are going to have an answer to be equal to 0. So that C is simply what we are adding to all our answers after we finish integrating, to be on the safer side that it is possible for us to have a constant, since the y over dx will not show us. For example, now look at this place. We have the y over dx of this expression y equal to x over 2 to be equal to x, and the y over dx of this expression x squared over 2 plus 5 to be equal to x, the same thing. So from this expression, these two expressions, we can't tell whether there's a 5 at the back of our y or not. Here there's no 5 and here there's 5, but we have the same answer. So to be on the safer side, we add c to all our answers, just to show in case there might be a constant behind it or not. In this case now, we're going to have c to be equal to 0, since there's no constant added to our expression. So in general, the answer y equals to x squared over 2 plus c is referred to as the general solution. And if you later get an answer in form of y equals to x squared plus 2 plus 1, in this case you already know that your constant is 1, then we refer to as the particular solution. So this is referred to as the particular solution. So this is simply the concept of arbitrary constant, general solution, and particular solution. So from this, we can now summarize that the general solution is given by y equal to x to the power of n plus 1 over n plus 1 plus c, where c is the arbitrary constant. Now let's look at some examples. The first example states evaluate integral of x to the power of 5 dx. And I would like to do something. I would like to further elaborate this better to see where this expression is coming from. How do we get to this point? Let's assume we have been given an expression f. We have given an expression y, which is a function of x. And from differentiation, derivative of y equal to dy over dx. And this equals x to the power of 5. Here, if you cross multiply, we are going to have dy equal to x to the power of 5 dx. So if you integrate both sides, this is integral of dy equal to integral of x to the power of 5 dx. So integral of dy equals to y equal to integral of x to the power of 5 dx. So this doesn't mean a lot, it's just to show us where the expression x to the power of 5 dx is coming from. So what we have to look for now is our y, which is equal to x to the power of 5 dx. From what we wrote in the previous slide about the general solution of integration, here we have here that y equals to x to the power of 5 plus 1 over 5 plus 1 plus c, and this equals to y equals to x to the power of 6 over 6 plus c, and this is the answer. So this expression y equal to f of x is simply this. So therefore, if we differentiate y, which is x to the power of 6 over 6 plus c, we are going to have x to the power of 5. To show you a quick tip of how to easily get this, let me talk about this. For example, now we are given y equal to integral of x to the power of 5 dx. So one way to easily get this is to assume dx is just multiplying x to the power of 5 by x. For example, we are multiplying x to the power of 5 times x. Just like try as much as possible to remove the d and put x here. So we can have that x to the power of 5 times 5, we are going to have x to the power of 5 plus 1. And simply put whatever you have at the top, put it at the denominator too. 5 plus 1 plus c. So this is a quick tip of how to easily get integration. This is x to the power of 6 over 6 plus c. We have another question here. Question 2. Evaluate integral of 1 over x to the power of 3 dx. So we don't need to talk about where this is coming from again. Let's just go to our question straight. So we have to integrate 1 over x to the power of 3 dx. To make this easy for us to work with, let's simplify 1 over x to the power of 3 to the simplest term. And this can also be written as integral of x to the power of negative 3 dx. So now we have to integrate x to the power of negative 3 dx. And as I told you in the previous question, just assume you are multiplying x to the power of 3, x to the power of negative 3 by x. So we are going to have y equal to x to the power of negative 3 times x, and this equals to x to the power of negative 3 plus 1. This is coming from indices over whatever you have as the power, you bring it here, minus 3 plus 1 plus c, and this equals to x to the power of negative 2 over negative 2 plus c. Then you can further simplify this as 1 over negative 2 times 1 over x to the power of 2 plus c. This is coming from indices, and then we are going to have minus 1 over 2x to the power of 2 plus c, and this is simply the solution. So y equal to negative 1 over 2x squared plus c. And that's it. We have come to the end of this tutorial. I have some exercises for you here, as I promised you. You have 3 exercises, the first, second, and the third one, and the answers are also given below. Try to attempt this, solve them on your own. If you have any problem arriving at these answers, you can post your question in the comment section below, or reach us at rolesacademy@gmail.com. Thank you.